Good morning, dear students. I am Amrita. I think in the previous video we already studied the kinetics of decomposition of hydrogen iodide. So if you see the decomposition of hydrogen iodide, so here the quantum yield is about 2. So that is xi is equal to 2. So the quantum yield is decreases as the reaction proceeds. So this is due to the accumulation of iodine. So for this reason, you have to write the thermal reaction for the decomposition of hydrogen iodide. So the thermal reaction is given like this: H plus I2 with the rate constant K4 to give Hi plus I. So this reaction becomes very significant. So if you include the thermal reaction in the reaction mechanism of the decomposition of hydrogen iodide, okay, and in the next part apply the steady state approximation to the concentration of hydrogen. It gives d into concentration of H by dt is equal to K1IA minus K2 concentration of H2 into concentration of Hi minus K4 into concentration of H into concentration of I2, that is equal to 0. Okay, so this is called as equation 4. So here in the equation 4, the K1IA is taken as outside. So now it will becomes K1IA is equal to K2 into concentration of H into concentration of Hi. The negative sign is converted into positive. So here plus K4 into concentration of H into concentration of I2. So here, if you observe this equation, the concentration of H is taken as outside. So here, this is the concentration of H is taken as common factors. So hence, this one is taken as outside. So now the equation becomes K1IA is equal to the concentration of H into K2 into concentration of Hi plus K4 into concentration of I2. Okay, so observe this equation. So now you have to find the value of the concentration of H. So if you take the concentration of H as outside, so now the equation becomes the concentration of H is equal to K1IA. So here the K1IA by K2 into concentration of Hi plus K4 into concentration of I2. So this is called as equation 5. If you substitute this equation 5 in the equation 1, so now it will becomes minus d into concentration of Hi by dt is equal to K1IA plus K2 concentration of Hi into K1IA by K2 into concentration of Hi plus K4 into concentration of I2. So if you observe this equation, here the K1IA is taken as common factor. So K1IA taken outside. So if you take K1IA, then it will becomes 1 plus write K2 into concentration of Hi as it is divided by write the denominator as it is, that is K2 into concentration of Hi plus K4 into concentration of I2. So now divide both numerator and denominator by K2 into concentration of Hi. Okay. So now finally you will get the value as K1 into Ia into 1 plus 1 divided by 1 plus K4 into concentration of I2 by K2 into concentration of Hi. So as the reaction proceeds, the concentration of I2 is increases and hence the quantum yield is decreased.